Right, these are your toxicology notes for our first unit of second semester. So make sure you're filling in your document as we go along. All right, first off, what is toxicology? Toxicology is the study of poisons as well as drugs, any sort of chemical substance that can be found in someone's body. Toxicologists study the harmful effects of these substances, the harmful effects that they may have on the body. Forensic toxicology is the science of detecting and identifying drugs and poisons a person may have used for medicinal, recreational, or criminal purposes. So in forensic toxicology, they're trying to determine if did they accidentally overdose? Did they purposefully take a large amount of a drug or poison? Or was it something nefarious, right? Did someone try to poison them? Right, there are 4 different ways that a person can be exposed to toxins. They can be ingested through their gastrointestinal systems. That means like through the mouth, into the stomach. They can be inhaled through the nose to get them straight into the lungs. They can be injected directly into the bloodstream. And they can also be absorbed through the skin in things like dermal patches. Forensic toxicologists are concerned with the legal and medical aspects of alcohol, drugs, poisons, and toxins in bodily fluids. They often work with pathologists to analyze blood fluids from autopsies. So pathologists specifically look at different tissues. Toxicologists will work with a pathologist to get different tissue samples from different locations in the body while doing an autopsy. They may be responsible for presenting evidence in court. So often a toxicologist in a case of a poisoning or an overdose or something like that may have to present evidence in court for what they found. All right, first we're going to talk about poisoning. In this unit, we're going to start with poisoning as our first little section. There's 2 types of poisoning. There is acute poisoning. Acute poisoning involves very high doses over a short period of time. One example of an acute poison would be cyanide. Cyanide is extremely toxic, as you'll see, and it produces immediate symptoms even when there's very small amounts there. So again, high doses over a short period of time. That is different than chronic poisoning. Chronic poisoning has lower doses over a long period of time. So these are substances that aren't immediately harmful, but if a person has prolonged exposure, they will have symptoms. For example, mercury and lead. If you're exposed to tiny amounts with just one time, you're not going to have a lot of poisoning effects. But if you have a low dose over a long period of time, you're going to gradually develop symptoms because of that repeated exposure. So low dose, long period of time. LD50 is the amount of a poison given all at once that causes the death of 50% of a group of test animals. This is the number that we use to describe how toxic a substance is. LD stands for lethal dose. 50 represents 50% of the test population. So we assume when 50% of the test population has died from a certain amount, that's what we call like the lethal dose. That's the point where it really becomes toxic. It's used to measure acute toxicity of a material. So again, acute toxicity means how much they're exposed to at one time, short period of time, just one exposure. Typically, when we talk about a test population, usually that's done with rats or mice, and then we use that data and extrapolate it to the size of a human. LD50 is expressed as milligrams per kilogram of body weight. So it's how much of that toxin do you have to have for each kilogram of body weight in order to get those toxic effects. If we have a very high number, if it's a high number of milligrams per kilogram of body weight, a high LD50 is a less toxic substance because that means we need more of it in order to kill the test subject. A low LD50 number means that it is very toxic because we only need a small amount in order to kill the test subject, right? So that's a little bit opposite of what a lot of students think. A high LD50, low toxicity. Low LD50, high toxicity. So let's look at some examples here. You can see on the table a bunch of different types of toxins. It says, using the table, which substance is more lethal, cyanide, nicotine, or caffeine? So if we look at cyanide, has an LD50 of 4 milligrams per kilogram of body weight. Nicotine, right here, has a LD50 of 10. And then caffeine has an LD50 of 250. So the most toxic is going to be the one with the lowest number. So that would be cyanide. You only need a small amount of cyanide in order to kill 50% of the population. We can also use these numbers to quantify the amount that you would have to give to a person based on their body weight. So it says how many milligrams of strychnine. Strychnine is the chemical in rat poison. How many milligrams of strychnine must be ingested by a 60-kilogram man to have a 50% chance of killing him? So remember, this number represents milligrams per kilogram. So to figure out how much we need, we're going to take the LD50 number and multiply it by the body weight. So the LD50 for strychnine right here is 2. So I need 2 milligrams for each kilogram. This person weighs 60 kilograms, so I'm going to multiply 2 times 60. I would need to give 120 milligrams of strychnine to have a 50% chance of killing that person. All right, the second part of our toxicology unit is going to focus on drugs. Drugs can be classified into 5 different classes based on their effects on the body. The first class is hallucinogens. Hallucinogens alter normal perceptions, thoughts, moods, makes people see things, feel things that aren't actually there. Some examples of hallucinogenic drugs are LSD, PCP, and marijuana is classified as a hallucinogen. A lot of students don't realize that, but it is classified as a hallucinogen. Narcotics, these are, if we're talking about prescriptions, they're used to relieve pain. So we're talking about strong painkillers, and they also cause the person to fall asleep. So examples of these would be any type of opiate, things like heroin, codeine, methadone, OxyContin. All of those are narcotics. Stimulants are going to increase alertness and activity. These are like uppers, as we call them sometimes. Examples would be amphetamines, including methamphetamine, cocaine, crack, and MDMA. MDMA is also known as ecstasy. Then we have anabolic steroids. Anabolic steroids are those illegal type of steroids that are very harmful. They promote rapid tissue growth. So examples of these would be Anadrol, Halotestin, and Anador. And then there are depressants. Depressants depress functions of the central nervous system. They cause the person to be calm and bring about sleepiness. These are kind of like the downers. So examples of those would be alcohol, barbiturates, and anything that we would think about as like huffing. So like glue, spray paint, things like that. Types of drugs. There are illegal drugs. Illegal drugs are defined as drugs with no current accepted medical use in the United States. These are drugs that are not used at all by the medical community. They're straight up illegal. Those would be things like heroin and LSD. These are things that are produced on the black market, sold only on the black market. That is different from a controlled substance. Controlled substances are legal drugs. They're legal under certain circumstances, whose sale, possession, and use are restricted because of the mind-altering effect of those drugs and the potential for the abuse. So these are drugs that do have some sort of medical use but require a prescription. These are things that are typically created by a pharmaceutical company. Examples of these would be prescribed narcotics, depressants like alcohol is a controlled substance because we have ages on it, and other stimulants, things like some amphetamines and things like that. The Controlled Substances Act was passed in 1970, and it established 5 different schedules of classification of controlled substances. Those controlled substances, their schedule is based on its potential for abuse, potential for physical and psychological dependence, and based on its medical value. So is there anything else, any other drugs on the market that can do the same thing with less potential for abuse? So psychological dependence means that the person believes in their head that they need it. So mentally, they think that they need to have it to go on with their everyday life. The conditional use of a drug caused by underlying emotional needs. These are people who think like, oh, I need to smoke marijuana before I go to sleep. It's the only way I'm able to sleep is if I do this. It's a psychological dependence. They mentally think that they need to have it. That's different than a physical dependence. A physical dependence means they physically need it. Their body will get sick if they do not get it. So this is a physiological need for a drug that's been brought about by its regular use. This is something that develops over a long period of time. Their body is so used to having that drug in their system that it does not know how to function without it. Physical dependence is characterized by withdrawal sickness when administration of the drug is abruptly stopped. This can happen from everything from heroin to alcohol. All of those, or both of those, have extreme withdrawal symptoms, or can have extreme withdrawal symptoms, as well as lots of other drugs. All right, the 5 schedules of controlled substances. So Schedule 1, these are drugs with a very high potential for abuse and addiction and no current medical value. So again, these regulations are set by the federal government, not the state government. So examples of these would be heroin, LSD, ecstasy, and marijuana is still considered a Schedule 1 drug, even though it is legal at the state level for recreational use and medical use. At the federal level, it is still Schedule 1. It is still considered to be of no current medical value. We'll talk more about that in class as well, kind of the issues that are caused by that. Schedule 2 drugs are drugs with a high potential for abuse and addiction, but they have some medical value with restrictions. So these are drugs that can be used in small doses or have been used in small doses in the medical community. For example, things like PCP, cocaine. Even though we don't currently use cocaine, historically speaking, it was used medicinally in the early 1900s, 1920s, 1930s. The schedules have not been updated. Amphetamines as well. Most opiates, things like morphine, some barbiturates as well. So Schedule 2 drugs, very high potential for abuse, but they do have some medical value, which is why they're one step kind of lower. So Schedule 3, these are drugs with less potential for abuse and addiction and currently have acceptable medical uses. These are some barbiturates, codeine, which is in like a lot of different cough syrups, and steroids. Schedule 4 drugs have a low potential for abuse and addiction and currently acceptable for medical use. These are tranquilizers, things like Valium, Xanax, Librium. And then Schedule 5 drugs it's the lowest schedule, so these are the ones with the lowest potential abuse, accepted medical use, and lowest potential dependence. So even if someone were to use these for a long period of time, the amount of physiological addiction is very low. So that would be some opiates with non-narcotic ingredients. So things like Polytussin, Zotex C syrup, those are types of cough syrup. So these are some painkillers that don't have narcotic ingredients in it. All right, let's talk about drugs and crime. Of the top 8 arrest offenses in the United States, drug abuse violations continuously rank near the top of the list. So if you look at the data on the side, total number of arrests in the United States in 2019 was just over 10 million. Of those 10 million, 1.5 million were for drug abuse violations, and then another million for DUI, so driving under the influence. Drug offenders make up more than half of the federal prison system and about 20% of the population in state prisons. So a huge amount of our prison population is from people that are drug offenders, that have drug crimes on their record. Over 25% of domestic violence disputes are drug-related in some way. And 81% of child endangerment cases are also drug-related. So obviously a huge problem in the United States with drugs just overall. Huge issues in terms of number of arrests, in number of related crimes, and number of overall prison population related to drugs. So what do we do if we come to a crime scene and we find drugs? At the scene, field examination of substances can be done to determine if drugs are present. So at the scene, we can do what we call presumptive testing, which we'll talk about in a second, to determine if it's actually drugs. If we do find drugs, we got to make sure we package it correctly. We need to prevent loss of contents or cross-contamination. If there's multiple kinds of drugs, we want to make sure that they're not, mixed together. We want to prevent any cross-contamination. So if we're packaging evidence, we can keep it in the original container. For example, if we find a bottle of pills, we would take the entire bottle with the pills inside. Any volatile substances that easily evaporate would need to be packaged in airtight containers to prevent evaporation. Packages marked with identity information, obviously identity information and chain of custody, just like we do with all pieces of evidence. And then we want to supply any background information regarding the drug's identity. So we want to note, did we find it with any other drugs or any other pieces of evidence that would maybe give clues as to what type of drug it may be. Drugs found at the crime scene are going to be sent to a forensics lab for testing and confirmation. We may do presumptive testing at the scene. Presumptive testing is going to narrow down the type of drug so that more specific tests can be done later. It's going to also determine if we find like a white powder, we can determine if it actually is a drug or not. So if it needs to be collected. So you can see on the side is an example of presumptive testing. So what they did is they added an example, a small sample to this little package. They shake it, and if it changes color, then the different colors represent different things. So you'll notice it doesn't tell us how much of the drug, it doesn't tell us how pure the drug is. In the case of the purple color that you see there, it doesn't even tell us exactly what drug it is. So for this one, this presumptive test just tells us, okay, that substance is either heroin, morphine, or Suboxone. All right, it's got to be one of those three. So then when we send it to the forensics lab, they know where to start additional testing. That's presumptive testing. That's just going to tell us, do we have drugs? What type of drug is it? And then we'll go on and do further tests. Confirmation testing is going to be done at the lab. That's going to determine how much of a drug is in the sample. It's going to confirm when, how much, or exactly which drug the person has taken in their body. So we can also get like blood samples and things like that. Examples of different types of testing they can do are color testing, microcrystalline testing, thin layer chromatography, gas chromatography, spectrophotometry, mass spectrometry, and neutron activation analysis, which is NAA. So they have lots of different types of tests they can do. That presumptive test on the scene is going to help narrow down which tests they should run. Forensic toxicologists also perform scientific tests on bodily fluids and tissue samples to identify any drugs or chemicals present in the body of victims or suspects. So they're not always looking for the exact drug, but also looking for metabolites of the desired chemicals. For example, if a person takes heroin, the body converts the heroin to morphine very, very quickly. So they're not going to be looking for heroin in the person's system. They're going to be looking for a form of morphine in the person's system instead, because the body has started to break it down. All right, so that is the end of your notes for toxicology. Make sure that you fill in all of the blanks and turn it in on Canvas.